Hello everyone, and thank you for joining us today for our webinar. In this presentation, you're going to learn how to use plate clamps safely. This webinar will review the safe use and inspection of plate clamps for lifting structural plates and profiles, including how to determine the proper size and type, understanding the mechanics and design of a clamp, and how to inspect and care for clamps. Joining me today, or presenting today, is Peter Cook, our training manager, covering rigging, hoists, and load securement. My name is Gisela Clark. I'm the social media and e-learning specialist at Columbus McKinnon and will be your host for today's webinar. We are recording the session today, and the recording link will be added to our YouTube channel as I mentioned. Everyone in attendance will be receiving a link to the recording. So, as I mentioned earlier as well, everyone is in listen-only mode, so we encourage you to ask questions in the Q&A pane on the right side of your page. Many of you have already been asking, which is excellent. I appreciate that. You've been commenting to my question at the start. As I said, we'll take 5 minutes at the end to answer them. Thank you all for your attention, and now I will turn the meeting over to Peter. And Peter, you are now ready to go.
Thank you, Gisela, and welcome everybody. Today we're going to cover how to determine the proper size and types for clamps, understand the mechanics behind them, and how to inspect them. And again, like Gisela said, I will answer any questions that you have at the end, and if I can't get to you, I will either email you or call you personally, depending on what the nature of your questions are. So we'll get started. So plate clamps, they are very safe when used correctly. They can be used for difficult lifts. They speed up production, and an operator needs to be trained how to use them. They're not just something that you can attach and go ahead and do a lift with. An operator really needs to know what it is it takes to select it and inspect it and understand how to use it safely. So let's start off with how a clamp works. So basically what we do is we push the teeth into the plate. So what that is, it's like nailing the clamp into the plate, right? So it becomes one with the object. So now what we have created now is basically what a clamp is. It creates a lifting point. So now you have a lifting point on a plate of steel that wasn't there before, which eliminates drilling or trying to do some type of hitch that may not be quite safe. You always want to position the plate clamp over the center of gravity so that we can have a nice controlled lift, and we'll explain that a little more as we go further in. So, how does the clamp work? Well, the more loading on the clamp, the stronger the grip. So it's kind of like those finger handcuffs. When you pull as hard as you can't get them off, and then if you kind of real light pull, they'll slip off your fingers. Well, think of a clamp working that way. It's probably the best example I can give of how a clamp works. So light loads for a clamp are kind of dangerous if you don't size your clamp right. You have a very weak grip, and we'll explain that even further why we were so concerned about lighter loads. But the stronger the grip, obviously the more teeth, the more we push those teeth into the plate, so we have more grip. The weaker, the less we can push those teeth in, so the weaker the grip, the less load, the less we can push those in. So we have the requirement, we have minimum load requirements for the clamps. And traditionally in rigging, you know, we would oversize things, like, oh, you know, if we're going to buy a shackle, well, you know, there's not much difference between maybe a half-ton and a 1 ton, and we could use both, and hey, we'll just go with the 1 ton shackle, or we just oversize things for rigging to be sure that, you know, nothing could go wrong. Well, that's not what we want to do with plate clamps. We want to size it exactly for the load that we're lifting. So here's an illustration of a plate and how the teeth push into the plate. And so basically the teeth penetrate the surface until the grip force is divided by the projection area and the material yield pressure. So therefore, if you have a very large clamp trying to lift a light load, you have too much area of tooth to push into that plate, and you just don't have enough grip to do that. So we want that strong grip for the most penetration of that tooth that we can. The softer material, the deeper the penetration. So with that said, the harder material, the less penetration we get. So we need to worry about plate surface hardness.
Peter, really quick, a question just I wanted to ask. Does the CM mark in the form of either a stamp or a sticker on the side of the clamp indicate what the minimum loading should be? And the second part of that question is, if someone had a clamp that does not have minimum loading marked on it, what should they do?
Yeah, that is a very good question, because typically in rigging you see the max loading of that clamp, and we just got done telling you that there's a minimum loading. So yes, CM does stamp the max working load limit you should utilize for that clamp, and the minimum working load we do stamp on the side of our clamp. So we do have that. In the event that you have a clamp that does not have that, we kind of do a simple recommendation is we use the 20% minimum loading rule. And what that would be is you just, let's just for simplicity, say you have a clamp that is good for a max working limit of 1,000 pounds. We'll drop a 0 off the end and times it by 2, so your minimum loading would be 200 pounds on that clamp. So you have to, so that's how you would do it if you didn't have that minimum loading on your clamp. But excellent question.
Okay, thanks.
You're welcome. So the friction between the tooth and the plate reduces the penetration, and it's going to cause wear. So we're going to talk about something. So wear, we don't want to see wear in our teeth, right? Because that's what's holding the load in the air. So we want to limit how much penetration there can be. So the engineers design it so they kind of play this cat and mouse game where you got to give a little and take a little, and so if we push in too much, then we're going to cause excessive wear on the tooth, and we don't want that. So that's really more of a design thing. So the tooth must support the load being lifted. The load is carried in shear across the tooth in the penetration area, and the design of the tooth is compromised between penetration, load capacity, and wear resistance. Those are the things that we take into consideration when designing that plate clamp. So obviously, inspection becomes important. So if we have damaged teeth, chipped teeth, that's a big deal because we've sized these teeth to carry the load based on the full tooth width. So we'll get into that a little bit when we talk about inspection. So let's talk about wear, because wear is going to be one of the biggest enemies of the plate clamp, and an operator needs to understand that. So the wear is dependent on the plate hardness. Obviously, the harder the plate, the faster it's going to wear. Plate thickness, weight of the load, how the clamp lifted the load, and how the clamp was fitted. What does that mean, how the clamp lifted the load? Well, a crane operator, they want to, if they're doing a vertical clamp, they want to stay over that center of gravity, so when it leaves the ground, they want to minimize swing. So crane operators are taught to minimize swing to begin with any load, but when you're lifting a plate, it can be a little bit tricky to do that. So if you get a lot of swing, you can get a lot of grinding of those teeth on that plate, and so that could cause excessive wear. And how the clamp was fitted. Was it fitted properly? And we're going to talk about that. So if it wasn't fitted properly and there's movement as we leave the ground, then that causes wear as well. So for wear to occur, 3 things must be present, right? The surfaces need to touch, the surfaces need to be under load, and the surfaces need to be moved. All those things will cause wear. So we need to reduce wear as much as we can. So some things that we normally do reduce wear, lubrication, but in plate clamps that is not a good idea. Lubrication would step out the surfaces from touching, but not a good idea with clamps. We want grip. Reducing the weight, well, we need load for the grip, and we just said, the higher the weight, the tighter the grip, so that's not an option for us either. So we have to try to eliminate movement, and we do that by clamping tighter. CM utilizes a cam, a spring-loaded cam, which gives us an initial bite on that plate. And so with that initial bite, we eliminate movement. So as that weight is being transferred to the clamp as we're lifting, we'll see minimum movement, whereas a clamp that doesn't have a cam or a spring-loaded latch will move slightly to initialize that initial grip. So and that's how we determine what our design does to eliminate some wear. Wear reduces plate penetration. So as that teeth wear, obviously the material's not there no more, so we don't push in the plate further, and so that's not a good thing. So at some point there's going to be so much wear where that the tooth can't not grip the plate anymore and will slip off. So this is where an operator needs to be trained on inspection and visually knowing if they're looking at a clamp and they know they attached it properly and they're going through their lift sequence, and then now notice there's a small gap between the back of the mouth of the clamp and where they originally put it. That's maybe a sign that that clamp is saying, hey, I'm starting to wear out, or the tooth that's being utilized is starting to wear, so it's moving down in the clamp. So these are things operators need to be trained and to look at. So what do we want to do to have efficiency for the clamp, to minimize wear, increase life, and have the best clamp for the lift? Well, we want to use a clamp with the closest work limit to the weight of the plate being lifted. This will give the jaw will give its maximum clamping force and penetration. So if we had a 1-ton clamp, ideally, and a 1-ton load would be the most ideal. Let's say the clamp, we also have a certain plate thickness that we can lift with certain clamps. We have plate thickness ranges. So you would want to choose a clamp with, let's say it's a max plate thickness of 1 inch, and it's a max weight of 1 ton. So a 1-inch plate at 1 ton would be the absolute ideal condition for that clamp to get the maximum tooth penetration and the maximum grip. And so that's what happens when you get that, when you use the maximum capacity, the spring will be stretched to maximize initial grip. Obviously, that can't always be the case, and so thus we go back to that minimum loading so that we have enough grip for that light load, so that's why we worry about minimum loading. Fitting that clamp properly, I just talked about that. Make sure we fit it properly, that we seat it all the way in on a vertical plate clamp, and I'll have a picture up that will show that. And a good crane operator will minimize swing, so they should be following the center of gravity throughout the lift if they're flipping a plate, and make sure they are not going to add any swing to that as it leaves the groove.
Peter? Whoops, hang on a second. Peter, a few questions have come in, and if you don't mind, I'd like to run them by you because they're good and I think they're timely. The first one is, do we offer hands-on training for lifting plates and I-beams for riggers or crane operators?
Yes, we have a qualified rigger course that we have at our Niagara Training Center that we actually flip plates. We have I-beams, and we flip I-beams, we lift I-beams. We also do it in our crane operator course that we offer here at our Niagara Center. So yes, we can do that, and we have a variety of plate clamps to use to practice following that center of gravity as the plate flips over, or flipping an I-beam from the I position to the H position, or vice versa, H to the I position.
Okay, here is another one. When is the best time to rebuild a plate clamp?
Unmuted.
Well, when you suspect any type of damage, when you're seeing excessive wear on the tooth, blunting of the teeth, and with each clamp we give you a wear criteria and what to measure or what to look for. So when you're seeing things that are, and when we get into the plate clamp inspection part of this presentation, we'll show you the things where you need to replace some things and rebuild it, and so we'll get into that in more detail.
Okay. Yeah, there's one more question that came in, but I'm going to hold off to the end. This is a question that came in from John. So John, hold on to your question. We'll ask it as soon as Peter's done, because I have a feeling he's probably going to be covering some of what you've asked. Okay? All right. Peter, go ahead.
Unmuted.
Okay, so we have plate clamps that don't have a hinge hook ring, and some that do have hinge hook rings. So our standard clamp, which we call a CZ clamp, is a vertical plate lifting clamp, or a 92 series is another one we use, doesn't have a hinge. And so therefore, if we're lifting a long plate, we don't want to use a double chain sling and connect the two clamps via a bridle sling or double chain sling and lift the plate, because that'll put a side load on that clamp. So the last thing we want to do is side load the clamp without a hinge. And so there you see a setup in that pictorial there of I shouldn't say a very long plate, but a long plate that would require two clamps to make the lifts, to make a nice stable lift. You'd want to use a spreader bar with straight drops coming down to lift that. We only want to lift one plate at a time. And we never want to try to lift multiple plates, because you're going to lose the plates by doing that. And you don't want to lift plates that are more than 250 degrees, because what you're going to do is affect the heat treat of the teeth. You're going to affect the bolts that are Loctited in there, so you can loosen up the bolts by doing that. So it's going to affect the integrity of the clamp when we lift too hot of a plate. So let's go through the loading sequence. And here's the vertical plate clamp, and a vertical plate clamp in the horizontal position is only good for half its load. It's really not efficient. So you don't want to lift plates horizontally. Put a vertical clamp in each side of a plate and use it to lift the plate horizontally. But we're just going to show here a vertical lift. So when it's on its side like that, obviously we are putting a side load on the clamp but we're not doing it. We're not putting a side load in the direction of the plates of the clamp. We never want to do that with a clamp without a hook ring. But and you can see in this picture, we're only good for 500 kilograms, and we're lifting a 1,000-kilogram plate. So okay. So, whoops, I went the wrong way. So as we're going through the sequence, you can see here how the load is transferring. So we got the ground taking half the load and the clamp now taking half the load. And then in the middle section here, you see at some point during that sequence, just before it leaves the ground or the pivot point, we see zero loading. And that right there is a very dangerous, it's a very small area, but for a crane operator, you want to quickly get that off the ground to get that loading on and to get to that third picture where you see the 1,000 kilograms transferred down and into the clamp. Because what we just said, once we have no load, what do we have? We have no grip, right? So if that was the case and we were to stop there, we could possibly lose the load. So we want to continue the movement of that plate. So a crane operator never wants to stop at that position, and for whatever reason, whether they, maybe they weren't sure about something, or they want to just keep the movement, get that plate off the ground because that could slip off at that point. It's a small area that it happens in, but operators should be aware of that.
All right, Peter, a couple quick things. Someone has asked that you get just a little bit closer to your microphone so they can hear you just a little better. And secondly, I have a quick question for you. If you need to hold a plate at the zero loading location, as shown in the picture here, for fabrication reasons, what would you recommend that they use?
That's a very good question. Yeah, because a misapplication would be to use that vertical clamp and stop there, and of course you see the zero loading, and if it's sitting down on another plate, you can possibly, it can walk itself off. If you're going to weld something, you're going to weld that plate in that position, it could walk itself off and injure somebody. So what we would recommend, instead of using a vertical plate clamp, we would recommend what's called a pulling clamp, and it's more like a vise. And the pulling clamp we do not recommend for overhead lifting or for a plate that's going to leave the ground, but we do recommend you use that type of clamp for positioning, and you're going to keep it in that zero loading position because, again, it's more of a vise. So then we're able to do the fab work that is needed if you're going to keep a plate in that position.
Okay, thanks, Peter.
You're welcome. Does that sound better?
Yes.
Okay, very good. So let's look at the types of clamps. So we basically told you how a clamp works and how a clamp gets loaded. So let's start off with just straightforward vertical plate clamp, and it can lift and turn plates 180 degrees or transport a plate in that vertical position. We showed for short plates one is okay, and I showed you that spreader bar for lifting long plates, okay, to do 2 clamps. Avoid a load 20% below the rated capacity, which we talked about that, so everybody understands why that is. We're worried about that minimum loading for grip reasons. So again, select the clamp as close as possible to the max loading, and this will ensure full tooth penetration. We got to watch out for surface hardness. Anything over 300 Burnell or 32 Rockwell C, that plate then becomes harder than the teeth. So we do not want a plate harder than the teeth of our clamp because it's not going to penetrate the plate and it will end up slipping off. Okay, and so we have we can get into we have a special high grip clamp that gets us a little higher in Rockwell hardness, and then we'll have to switch to a non-marring clamp or a clamp without teeth that uses friction if we have a very hard plate, and I'll show you an example of that. So here's a step up from the standard CZ or 92 series clamp, which we call our CY clamp. And this clamp does have a hinge and can be side loaded. You can use this clamp on a double sling to lift plates. Okay, so if you have to flip a plate from end to end, and which results in a side loading of a clamp, this is the clamp you want. Or you don't have a spreader bar and you want to use a double chain sling because you have a long plate, then this is the clamp that you want. And we give charts on the capacities that you'll have based on the angle of loading and things of that nature. Again, this one, it's clamp with teeth, so it still would have minimum loading on there stamped on there that you need to worry about. So it's a little bit more of a bell and whistle that you can have, or an option that you can have to step up from the standard clamp, which is that hinge clamp. And here just shows the loading of that clamp where you get 100% obviously when it's in the vertical position, and then when you side lift, the one to the right there shows the side load. If you're going to do a full side load, again that 50%, and it increases as you get to the straight vertical. So, but that hinge will end up taking that side load. If you side loaded a standard clamp, you're going to bend the shell plates out, and it's going to distort, and so you don't want to do that. So here's the non-marring clamp. So again, if we had a plate that was over 300 Bernal or a stainless steel plate, we want to use a non-marring, which we call LJ clamp. It has a leather jaw on it, and it gives a nice grip. It's based on coefficient of friction. And also we can lift a little bit lighter loads. We don't have, this isn't a clamp with teeth, right? Still has the same principles, but we can go a little bit lighter loads with the LJ clamp. But it does have some drawbacks. If you have an oily surface, obviously friction and oil, you want friction, and oil doesn't quite work when we're trying to overcome the coefficient of friction. Or if it's a lot of dust or mill scale on there, again, that's going to clog up the leather, and it's going to become a slippery surface, and so we don't want that. So, it's a high, when you use a non-marring clamp, it's got to be looked at, inspected. You got to make sure the lifting pads are clean at all times, and the surface that you're doing is clean at all times to be sure that you're going to get the correct grip.
Okay, Peter, I have a couple more questions. The first is, it says using non-marring for stainless steel, but why would this not be the case for a normal vertical clamp? Oh, I'm sorry, just a sec. Oh, there we go. Go ahead.
Very good question. We get asked that a lot. Hey, our stainless steel isn't over 300 Bernal. Why not stainless steel? We found with stainless steel has kind of a skin to it, and what happens is the teeth penetrate that initial skin to get initial bite. It has to go through that. It's kind of a hard surface, but very small, in a case step, but very small. But it wears our teeth quickly, and so we see accelerated wear with a clamp with teeth. So we do recommend a non-marring clamp, or we have what's known as a high grip clamp, which kind of works well with stainless steel. So either or would be good. The non-marring is probably where we go first, or the high grip after that. But
okay.
Good question.
Okay. And we have another one. You're going to be covering plate inspection, aren't you?
That's correct.
Okay. This other one will be for that. Thank you.
Okay. Okay. So I mentioned you don't want to use vertical clamps to lift plates horizontally. So if you've got to keep a plate in the horizontal position, you can see there, if you have a small plate on a sling and one on each end, we work fine. We sell these in pairs. And if you have a long plate, then again, we want to utilize that spreader bar, and we want to have two double chain slings coming off each end. And so what we're kind of doing there, we're kind of bear hugging that plate. We never want to use a quad sling or a four-legged sling in place of a spreader bar, because that will turn those horizontal clamps, and they could slip off, and that's not the correct way to utilize those. So you can see when you're lifting a long plate, that is the correct rigging setup for it that you would require. A lot of people ask me, what is a long plate, what is a short plate, and it's kind of relative. It all depends on the width and the length. Certainly, if I had a 1/4-inch plate that was 10 foot long, is not going to react, and maybe 3 foot wide, is not going to react the same way if I had a 1/4-inch plate that's 10 foot wide and 20 feet long. It's going to react differently. It might have more sag to it, things of that nature. So you're going to have to have a good idea of how your plate and the integrity of your plate is going to be. It's just not a simple question to ask. We can review that with customers if they're, when in doubt, what would work best. We sell what's known as beam clamps, and our beam clamps that we sell at Columbus McKinnon we use for suspending off an I-beam, whether you want to suspend a hoist, a hand hoist, or an electric hoist. And we do not recommend them for lifting I-beams, and it can be misapplied by doing that. And this is more of a vise-type clamp. Another thing you don't want to use is a welder's type clamp that you see there. That's really not, you see that misapplied all the time. So if I was going to lift an I-beam, what clamp do I need to clamp onto that I-beam? And so we have what's known as a CG clamp, and you can see down in the lower right-hand corner, it's a little bit different than that vertical. It says correct and wrong. The wrong is our traditional vertical clamp. where the you can see in the girder clamp that mouth is kind of moved around a little bit. And if you look up at the drawings of lifting these just section of I-beam, you can see when we have one clamp how it holds that I-beam, and the clamp never really comes truly around in that vertical position. So therefore, if we use a standard clamp, it wouldn't be efficient lifting that I-beam because you're never going to get it true, never going to get the clamp true vertical. So therefore, we have a special clamp that will do that. That's efficient for lifting I-beams. That'll give it enough grip when in that position. What's nice about it, if you use these in pairs, you can flip I-beams with it. You can turn from the I position to the H position, or H from the I. So it makes for a nice lift point to flip an I-beam, which can be a difficult task, or if you're doing it with traditional slings, you can end up shock loading a lot of times. And again, for short I-beam sections, one is okay. For long, you're going to use on a spreader bar, and you're going to put on the opposite side of each other, and it'll be a nice, easy lift, quick lift to do that with. So let's talk about plate clamp inspection. So this is ASME B3020. Clamps fall under that, the B3020. They're a below the hook lifting device. So that's the standard you want to get as far as the inspection criteria for clamp, as well as the manufacturer's inspection criteria. We want to inspect clamps 1 to 4 weeks depending on use, and always check for smooth operation prior to each use. You make sure we get any grease, mill scale, grit, dirt out of those teeth, right? If we have mill scale or anything that's clogging up the teeth, you're going to get less penetration. So again, the operator needs to look at those, make sure they're cleaning those up before they're using them. Make sure they read the operating instructions. If in doubt, change component repair and only use the original manufacturer's parts. So if you have a CM clamp, you want to use CM parts. If you have another manufacturer's clamp, you want to get their parts and not try to retrofit. So let's start out with teeth. Chipped teeth are only acceptable if the chip is less than half the width of the tooth and the 2 adjoining teeth are undamaged. So we talked about tooth penetration and how the teeth profile, the tooth profile holds that load. So we can tolerate one tooth being chipped that's being utilized. So you're going to have to look at the teeth that's being utilized. It depends what plate size you use as well. As you turn that cam on the plate, you'll see that it can go from a 1/4 inch plate all the way up to 3/4 inch plate, or sometimes larger. And you want to see what teeth are being utilized for the size plate. And you can just do that by turning the cam to the plate width that you're lifting, and you can check out those teeth. So if I was lifting a 1/4 inch plate, I'd want to turn the cam until I had a 1/4 inch gap or a little less in the mouth of the clamp, and I would look at those teeth that are going to be utilized to lift that size plate. Obviously, the different size thicknesses, it utilizes different teeth projections on the cam itself. The fixed pad, those of course would always be the same.
Peter, on that note, this is the question we've been waiting to ask. John asked, I've always been told that when teeth get chipped, you have to replace the teeth if one tooth is chipped more than 1/4 of the length of one tooth. Is this a true statement?
Yeah, and again, there is our criteria there, and so if the chip is less than half the width of the tooth and the adjoining teeth, which means the tooth above it and below it, are undamaged, then you're okay to go ahead and use that to make a lift. Okay?
Thanks.
So that's the criteria right there. So John, that question was actually answered in that slide exactly.
Perfect. Thank you, Peter.
Okay. So again, the teeth definitely are going to be our really, we're going to scrutinize and look at those. That's of course, that's going to be our biggest function of the clamp. Then of course we want to, and not the only thing, but it's the most important part of the clamp. We want to look at that hook ring. If it was side loaded, is it bent, or the side plate's bent? Spring damage, maybe the spring has been stretched and it hasn't gone back to its original position. We can only batch test springs, and so we will test batches to destruction, and so therefore it is possible that a spring could fail here or there. We test out our spring manufacturers all the time, but it can happen, and you want to replace the spring if you suspect that. it's stretched, and it's pretty tight when it's compressed, and if it's not, probably that it needs replacement. Yeah, any deformation, hook elongation, excessive wear on that hook ring. You want to check the bolts, any pit or rivets, and make sure they're secure, that there's nothing loose in there, and any wears on pins, things of that nature. So anything that's causing you concern, it's definitely, you want to take it out of service. As far as the bolts, you're going to want, if you're going to replace bolts or anything, you're going to want to get them from us, because a lot of people say, well, I can just go get those same bolts, grade 8 bolts. You got to remember, we product test everything. We product test the suppliers that supply us those grade 8 bolts, and we validate the integrity. So you don't, and that's why we say use only original manufacturer's parts, because if you put someone else's bolts in there, the integrity was not checked out by us, right? We don't know what their process is. It could very well fail, and you can't guarantee that we have put everything that put into our products through all the stringent testing that we do before we go to sale. So you want to take these clamps apart. They are like Loctite. Those bolts are Loctited, so you're going to have to slowly warm them up. And you can do it with a heat gun. You don't want to, of course, you don't want to use a torch or anything, but slowly warm them and keep checking. Keep checking to see if they become loose, and you'll see eventually they'll just break free. We use a Loctite grade 270, so when you put the clamp back together, you want to put that Loctite 270 back on there. We're looking for indents. Let's say we have a sloping slot there, and that sloping slot that CM utilizes, it gives us how we create our tension. And if someone was using a clamp incorrectly, say they're overloaded it or they weren't true vertical, what's going to happen is you're going to see an indent somewhere along that sloping slot. It's going to actually, the pin is going to actually push into the plate, sort of like a witness mark to say, hey, that clamp was used incorrectly or overloaded. And so therefore you'd want to replace the side plates, things of that nature, if they were damaged with that indent in there. Mouth not being parallel. How does that happen in an overload situation, right? That plate tries to squeeze out, so it tries to open up the mouth. So it's pulling, it's because it's too much weight for that clamp and it wasn't strong enough, so the mouth actually will open up. You'll see paint flakes on there, and they just won't be parallel. So that's something to look for. So you can check the neck spread out, document that, and look at each clamp. Look at each clamp's in the manual. For each clamp you get, it'll give you the criteria for that. If you're using with a chain sling, you be in accordance with ASME B30.9. Now I recommend with all vertical clamps that you use them with a small chain sling. You just don't hook your crane hook or your hoist hook directly into the clamp. If you have a heavy hook block and you were to set a plate down in the vertical position, you possibly could pop the clamp open because it's just too big to be sitting in the hook ring, and it could pop the clamp open. So we recommend a small sling in between the hoist hook and the plate clamp. It gives you a little bit of play there, so you won't pop the clamp open. And then we have the handle. So if we have a bent handle, a lot of people, they don't remove the tension off the clamp, and so they can't get it off. So they'll start taking a hammer and smacking the handle with it, which will damage how that cam works. And so if we see that, we want to replace it because it's going to have upward movement, and it's going to reduce the initial grip that we want. So any handle damage, we're going to want to replace.
Peter, on that note, I would like to go ahead and ask a polling question to everybody. So here it is. I'm going to launch it here. So what are the key things to consider when selecting a plate clamp? Is it the weight of the plate, the plate hardness and size of the plate, or is it number 2, temperature of the plate? Number 3, plate orientation when lifting and setting back down, or all of the above? And thank you, Mark, for giving me your answer there. If you have an iPad, you're not going to be able to answer the poll, so you can shoot me your answer via Q&A like Mark just did. Thank you, Mark. So again, what are the key things to consider when selecting a plate clamp? And it looks like a good majority are going for number 4, all of the above. We got a few citing for number 1. Yes, we've got Patrick who also shared. Yeah, Jody, excellent. A lot of you must be on iPads. Great. It looks like the great majority, about 95% vote for number 4. Okay, Peter, let me put you back on, and you can tell us what the answer is.
Yeah, all of the above. We got to worry about, we got to worry about the weight, the plate hardness. We have to worry about the size of the plate, the temperature. So all the above is definitely we want to consider to be sure that we're selecting the right clamp for the job. Right. With that being said, we kind of hope this helps you at least kind of give you an idea how clamps work, operators being trained on it, and how to select the right clamp. Oftentimes when I go on audits, you'll see one clamp being utilized for all plate sizes and all weights, and that's wrong, and it's the wrong doing it. Really, if you're in the plate handling business, you should probably have at least a half a dozen clamps, depending on the variety of plates that you have, to be sure that you're selecting the right clamp, you're getting the right grip, and it's the most safe clamp for that type of lift. So that's ideal for plate clamps, to have something to choose from and kind of train your operators, or even chart it out. Hey, these size plates we're using this clamp, these size plates we're using this clamp. Train them how to inspect it properly. One thing, just share a quick story. I was doing an audit for a company, and an operator was lifting a plate, and noticed the clamp looked pretty beat up to me. And we went over, and I said, let's go look at that plate you just lifted. And we went over and took a look at it. I said, show me on here where you connected the clamp, and he pointed to the position on it, and there were no marks on the plate. He's using a clamp with teeth, and there's no marks on the plate. I said, a clamp with teeth, those teeth have to penetrate into the plate, and it's going to create a mark on that plate. It's just how it works. And there was no marking. And so we took a look at the clamp, and therefore we saw that the teeth were very blunt. And so it was an accident waiting to happen, where that plate, if he was trained properly, that's one telltale sign that when hey, there was no marks on there, there's something wrong. There should be some marking on there. And so we made sure we got him the right clamp for the job.
Excellent, Peter. Thank you for that. Another request has been made to speak a little bit louder. And then the second thing is another question. You said, let's see, use a sling between the hook and the clamp. Is it okay to put a piece of chain in the eye of the clamp and bring them together with a hammer lock? Or is this not allowed since you're hooking the chain into itself?
Unmuted. No, you can do that. You just want to be sure that, you got to watch how that chain renders itself, and if you're doing a vertical lift, that it doesn't snag on anything. So that's just basic operator training there. But that's allowed. But then, of course, if you're going to so basically what happens is that clamp becomes a permanent part of the chain sling. So you need to be sure you stamp that tag accordingly, and many times it's the clamp that's the weak component in that sling, so you will not tag that sling for the chain's working limit. You may have to tag it for the clamp's working load limit, because that would be the max load, right? Because slings are tagged and the clamp becomes part of the sling. So that's you just got to be aware, and I see that mistake happen all the time. That someone will make a sling, which is nothing wrong with that, with the clamp attached to it, and they'll be tagging it with the chain's working load limit. And in this case, what I saw, the clamp was much weaker than the chain, and the tag on the sling still said the chain work limit. It could be that the clamp may be higher work limit than the chain, so the chain work limit would be the minimum loading that you could do on that if you're connecting it directly to the chain.
Okay, whoops. Okay, Peter, a couple more questions have come in, and we have 5 more minutes left, and we want to make sure everybody leaves on time. We don't ever like to run these over. Okay, so we'll take a few more. So when lifting a plate from the horizontal position, should we lift? Hold on a second. Yes. Okay, so when lifting a plate from the horizontal position, should we lift from the cam side or from the pad side? Peter?
Unmuted. With our clamps, it doesn't matter. Either or is okay. So whatever, and whatever your situation is, whatever works best for you is fine. You just want to be sure that you push that clamp all the way in where the plate is up against the top of the mouth of that clamp. And then and if you're flipped up on the cam side, you want to be sure it doesn't walk off. So you want to put some pressure with your hand on there, so as you're turning the cam, you're not going to walk it off the plate a little bit.
Okay. Thank you, Peter. All right, a couple more questions. Nameplate data as part of the inspection. That's one question. And let's see. If you lift a 2-ton beam with 2 1-ton clamps, is this acceptable? That's the second question. Okay, Peter?
The first part of the question is yes, it's a below the hook lifting device, so it would be the markings that is required under B30.20. So you're going to have the manufacturer, the working load limit, okay, a serial number. You're going to have the design category it was for, because it is a below the hook lifting device. And you're going to have the weight of that clamp. If the clamp weighs over 100 pounds, then the weight must be on there, so that you subtract that out of your, you don't overload a crane or a hoist. So the requirement is the weight of the clamp be on there if it is over 100 pounds. And can you repeat the second part of that question, Gisela?
Okay, just a sec. Okay, the second question is if you lift a 2-ton beam with 2 1-ton clamps. So a 2-ton beam with 2 1-ton clamps, is this acceptable?
Unmuted. So the minimum, the 2-ton beam with two 1-ton clamps, right? The minimum loading on that on those would be, so it'd be 4,000 pounds. So 800 pounds is what those clamps would each be. The minimum loading for each clamp would be good for. So that would bring us up to 1,600 pounds for minimum loading, split between those 2 clamps. And was it a 2-ton beam? So we would be okay there.
Okay. Okay, great. Just for everybody, if you have any more questions, type them in. We've run out of time to answer them because, like I said, we like to end on time. But Peter will personally respond back, so you can type that in. And I have another quick polling question to ask before Peter just wraps it up for today. We just wanted to get a little feedback from you. If any of you are interested in becoming a certified rigger or taking any inspection or rigging training, yes, within 1 to 3 months. Yes, within 3 to 6 months. Yes, within 6 to 12 months, or no, I'm not interested. We just love to get feedback to know, again, if you'd like us to contact you about that, or just to get feedback in general of your interest. And if you're not interested, like I said, it's no big deal. We just like to get your feedback. Perfect. We appreciate that. Just give it another minute, another couple seconds. Thank you. All right, excellent. And I will close now and turn it back over to Peter, who will wrap up the session for today. And I have one more request. If any of you are like a group of more than one, let us know. We like to see, how many from your company are attending. If they're a group together, just shoot me a quick Q&A. We just love that information. We found out recently that there was a group of like 7 or 8 that like to attend our sessions on a regular basis, and that was great feedback for us to get and reach out to this company. So, like I said, we want to provide you as much support as we can, and if there's a group attending, we love to know. So thank you for that. Okay, Peter, now you can wrap up the session for today. Oops, hold on a sec. Oh, just a minute. All right, Peter, go for it.
Oh, yep, thank you. Yeah, just real quickly for that last question, just remember your last question was asked about the beam clamp. Just remember your minimum loading that applies for any clamp with teeth. Use your 20% rule. So you're obviously, if you're using 2 clamps to lift something, you're dividing the weight by 2 to begin with, and then check out your 20% rule that I told you, dropping a 0 off the end of the max working load and timesing it by 2, and seeing if you're still within the parameters of that clamp. So I just want to just kind of reiterate that to be sure I explained it correctly. Some upcoming classes that we offer. we have in July an overhead crane and hoist inspection certification class, and that's July 29th to the 31st. The overhead crane operator qualified rigger workshop that was at our Niagara Training Center is August 18th to the 22nd, and the qualified rigger is incorporated into that. If you want to be crane operator, or if you just want to take rigging, it's 19th to the 21st. That's where we do go and lift plates and I-beams, things of that nature during that workshop. It's some of the exercises that we do for our hands-on activity during those two workshops. In September, we have a chain and wire rope hoist repair certification. So if you're interested in learning more about hoist and how to repair hoist, that's in September 8th through the 12th, and that covers wire rope and chain. And if you don't get into the wire rope hoist and you just strictly want to stick with chain hoist, that's September 8th and the 10th, and September 16th through the 18th. And that goes through manual hoist, electric hoist, air hoist. So some very good hoists. So check out our training page at cmcodepot.com and see what training works for you. And a lot of these courses we can do on site as well. If you have a crane available and proper rigging equipment, we could do some hands-on. A lot of times we find that on-site training for rigging, we can go through our course, but it ends up being more classroom than hands-on. For the simple fact is, it's just tough to get crane time in a production area, or interfering with production, or that some of the equipment isn't quite right, so that we really don't end up making this. But it's still valuable information because we can recommend, hey, we need to do this, we need to switch that up. So sometimes on-site is better or more economical for people with large groups.
Okay, I'll take it over. Oh, go ahead, please.
Go ahead. Nope, I was gonna just talk while I think you're better at this one.
Okay, no problem, Peter. I just wanted to let you know, first of all, thank you everyone for coming today. I just wanted to highlight that there are other ways you can follow us beyond today. We have a blog. You can find all of our social media links on the top right page of our website, which is cmworks.com. You can see on the very bottom of the page, we have a blog with over 125 articles that you can subscribe to. Tons of great technical information written by 20 different people, 20 different associates representing a variety of different disciplines within Columbus McKinnon. You can also find us on Twitter, Facebook, YouTube, LinkedIn, and Google+. So connect with us there. We love to see you. We love engaging. And again, thank you, everyone. If you have any final questions, you can type them in, and Peter will contact you. And as I said, you will receive a link to the recording within about the next day or two from me. So again, we appreciate all your time and attention and wish you a great weekend ahead.
Thank you, everybody. Take care.